Dr. Meadow is just such a valuable asset to the university with all he can add with his great knowledge. And again, I just want to let you all know how lucky we are that he is willing to come over and do those lectures. And we don't pay him anything extra. He just does it because he's passionate about what he teaches. What I'm going to try to do in this video is I'm going to try to focus you on the higher level things that I want you to learn. I know that most of you aren't geologists, you're not interested in being geologists, and so what I'm going to try to do is condense down some of the major topics that will allow you to understand as a non-geologist what you might want to keep in mind. So I'm going to be flipping through some of the slides. You'll see me occasionally glancing over to the sides because I have slide numbers written down for what I want to cover. So this is the first slide. These are the elements of the petroleum system. You're going to want to be very familiar with this slide. This is largely a restatement of the same thing. Make sure that you understand the importance of timing. Also, one of the fundamental things that's a little bit contrary to what you would think is that actually petroleum and natural gas, no surprise on gas, they are less dense than subsurface water, and that means it moves upward. And that's a key part of the migration. And understanding that principle will help you understand a lot of things throughout time on the just how things work. So just as a reminder, this is the idea of conventional reservoirs and how you have the source rock, the migration, the trap, and if there's no trap, it comes to the surface as a natural seep. You, again, in the reservoirs, you're looking for good porosity and permeability, and this is a review of those concepts. Now we talk about the self-sourced or the unconventional plays, and this is where the source rock, you're actually drilling into the source rock, which typically has low permeability, and it's typically done with horizontal kinds of wells involving combined with fracking. Okay, forward quite a bit. Again, just to reinforce the petroleum system, these are the things that you're thinking about. And incidentally, if it's not clear, I am reviewing the slides from, this is the first geology lecture. So he touched on the idea of improved oil recovery and then enhanced oil recovery. Improved oil recovery, the nature of the oil doesn't change. You're simply trying to do a better job of getting it to the wellhead. A lot of times it's a water flooding project. Sometimes it can be injecting gas to keep a gas drive going or infill drilling. Enhanced oil recovery, the difference is when you do enhanced oil recovery, you actually change the chemical properties of the oil. And we'll be talking about this more in the second block of material. But the thing I want you to remember down here is this is why you do it. Primary recovery, not going to pull out as much oil. Secondary, you get more, and it's only with tertiary. And just to reinforce what Dr. Meadow emphasized, whether you do these things is always an economic question. And actually, you're going to see later on, we're going to do some examinations of that in class to let you see the kind of numbers that we're dealing with. So that is the review off of the first lecture. I'm now turning to the slides in the second lecture. You're going to see there's not as many key points out of the second lecture because this is more what I would call the traditional geology, and I'm going to ask you to focus a little bit more on the unconventional because right now in Texas and in the United States, the unconventionals are what are drawing a lot of attention, and for some reasons I'll discuss later, a lot of people think they will continue to draw a lot of attention for a long time. But in this, remember, this is when you're evaluating a reservoir, you're looking at these issues because that would suggest that this is going to be a hospitable place to drill. Then two, if you remember, Dr. Meadow made a great discussion of the idea of data sparsity for geologists and how they're being asked to make decisions about where to drill on relatively imprecise, or I should say incomplete data. Part of the data they do have available, although albeit in very limited spots, is this idea of logging. Now, I'm not going to ask a lot of detailed questions on the particular logging, but I want you to understand logging at a fairly high level, which is what's it involved. They're trying to find out, uh, based on the rock, what type of rock it is, whether it holds oil, and then what percentages of these fluids it holds. Again, you see this uh, very similarly and in this slide. So you're going to want to be familiar with Dr. Meadows' discussions of these concepts as pertains to logging. And from the second lecture, those are the things I want you to focus on. Because the third lecture pulled a lot of the two previous lectures together and also talked about unconventional, there's a lot of material out of the third lecture that I want you to be familiar with. Again, just as a review, as far as the stages go, you start with primary production. Then you might consider improved oil recovery. You might consider enhanced oil recovery, and then field abandonment. As far as conventional reservoirs, I want you to be familiar with the various types of energy drives that are associated with this. And this is when you get into a reservoir, what keeps the oil flowing. So be familiar with water drives, gas drives, and this sort of reservoir energy. And notice where it says this is what tends to be the importance of what produces the drive. And then you can see, I don't want you to be responsible for the percentages, but just be knowledgeable of how these things might rank relative to one another based on the upper ends of what you're likely to get out of it. Again, this is just a review of improved and enhanced oil recovery. And same chart again. Why do we do these extra things? To get more oil out. And again, that's an economic decision. Dr. Meadows talked a lot about the various techniques of estimating how much oil is in place. When you're dealing with the unconventionals, a lot of that is just based on decline curve. They do a lot of decline curve analysis, and you're going to see us use this technique later in the class when we talk about production or forecasting. So that's, of all the analysis he talked about, this is the one that I want you to be familiar with. And then he talked about there are two types of declines: the exponential, which tends to be pessimistic, and the hyperbolic, which tends to be optimistic. And he talked about how the hyperbolic is what the Security Exchange Commission, or SEC, requires publicly traded companies to do their estimation of the oil in place. One thing that he did not emphasize is that, relatively speaking, conventional oil fields decline at a much slower rate than do unconventionals. Unconventional, you go in and you frack. It has its impact. The initial production rates are very high, and they taper off very quickly. And you'll see this later in the course as we look at some real data. Excuse me. Here we talked about the fact that decisions aren't really very good. Typically on these big conventional projects, people overestimate what they actually see. Going forward quite a bit, and I really don't want you to be too familiar with that decision making. Now let's get into the unconventional versus conventional. So you're going to want to be familiar with this slide. Incidentally, he's absolutely correct that they can run as high as 25 million, but now horizontal wells, today you're probably able to see them, depending on the location, in the 2 to 3 million range for even a fairly large horizontal well. Again, just a review of the differences between the two. I also want you to be familiar with this term resource plays, because this is what you hear. And so when they talk about a resource play, they don't think there's a lot of risk in knowing that the hydrocarbons are there. Sometimes there is still risk of knowing how much you're going to be able to get out of it, but you'll hear this terminology of a resource play. Incidentally, you'll talk to companies, what's your success rate of finding a good well? In a resource play, they'll talk like 90 to 95%. So you get into here very high probability, which has an implication for the land side that we'll see in our discussion after the exam. Again, a map Going to want to know the map. Then we talked about what changed the game. And remember, fracking has been around for a long time. What was relatively new is this ability to steer the bit horizontally. Now, the slick water fracking was a significant advance in fracking technology, but I don't want you, the main thing is I don't want you to think that fracking itself is new. The horizontal drilling is new, and they're always getting better at this fracking game. We'll talk more about this in the production side, but a couple of key things I want you to know is I want you to have a good feeling for the recipe for fracking, which is to say it is largely water, and 90% of a frac is liquid, and 99.2% of that is of that 90% is water. Some people say 99.5%. But again, he gave you really good lead in to indicate that, hey, it's not these horrible, horrible chemicals. There's some stuff in there that's better than others. Notice here's where you get the 99.5% that people sometimes will talk about. And also made the point that you can see this is 2,000 feet, and you can see here the fracs were a minimum of what, 4,000 feet below the aquifer. Then we talked about earthquakes, and Oklahoma has been the epicenter for earthquakes. And then you can just see all these earthquakes that started occurring. And he has a great summary slide here where they went from just not hardly any earthquakes at all to a spike. But the key thing is, it's not the fracking that's causing the earthquakes, it's the disposal of the water. And the reason that these earthquakes have trended down is they've throttled back the amount of water and under what pressure they're able to inject into the injection wells. There's that map again. That might be pretty important to know. Then he did a great job of talking about the importance of thermal maturity and how you see these zones. Notice that the zone in Ohio, this is in the Marcellus, this is largely oil. Then you see the wet gas, and that's that transition where it started to get a little bit hotter. And then here you see the dry gas where it was sufficiently hot, where it all converted to natural gas. And a reminder of the natural gas window that we see over here. Or I'm sorry, the gas, or the window for the various temperature and its impact. Okay, not gonna dive into this stuff. Got a great repeat slide here. Now we're into the Permian Basin. Dr. Meadow added quite a bit. He changed his lecture quite a bit from last year to put a lot more in about the unconventional plays in the Permian Basin, specifically at my request. This is the hottest place in the United States for drilling, that being the Permian Basin. And I want you to understand why. You're going to see later in the course, one of the reasons why is it has excellent cost economics because it's a very mature area with lots of service companies, but also pipelines that are readily available for product, and that's important. However, the geology is very good. Remember, we talked about this being the Central Highlands, which is where the drilling was for many years because these were conventional oil reserves. And now you have the unconventional plays, which are on both sides of the Central Highlands, that are getting a lot of attention. So it's a very sweet spot. And I want you to understand this. This is the Central Basin. This is the Texas-New Mexico border. And right around in here would be where the town of Midland is. So I want you to know the Delaware Basin, the Central Highlands, and the Midland Basin area where the drilling is taking place. And here's how I remember it. The Midland Basin is where Midland is. The Delaware Basin is that other place which, even though Delaware is on the east coast of the United States, the Delaware is to the west of the Midland Basin. This is where a lot of the drilling activity is, and this is where a lot of the drilling activity is. And again, we'll see that later when we look into drilling info. So I expect you to know those basic facts about the Permian Basin. Again, just to reemphasize, this is where a lot of the things are happening. I was going to have you read, but decided not to, a USGS geological report. And basically it says there are decades of oil in the Permian Basin in these unconventional plays to be produced. So there is a lot of oil there. Again, to confirm the rig status, I was surprised the data showed that there were this many rigs operating in the Eagle Ford. The thing I want you to walk away from is the Permian Basin area is currently the hottest play in oil. And what will happen if oil prices continue to rise, you'll see more rigs in the Eagle Ford and more rigs up in the Bakken because they become more economic. In here, this area is economic even with oil in the mid 40s to around $50. And that is it for the review. Again, for the exam, it's going to be 25 multiple choice, a page of short answer, fill in the blanks. Some are going to be application questions. And then there will probably be a map associated where I ask you to draw in the various plays. Good luck. Call me over the weekend if you need me.